Hey, what's up everyone? Today we're diving into some physics MCQs, so grab your notes and let's get started. Question 1. Who presented the corpuscle theory of light? A. Huygens, B. Newton, C. Young, D. Maxwell. Pause the video and guess your answer. Correct answer B. Newton. Explanation. Newton proposed the corpuscle theory, which describes light as small particles traveling in straight lines. This theory dominated for centuries. Question 2. Which phenomenon does not explain the wave theory of light? A. Polarization, B. Interference, C. Diffraction, D. Compton effect. Correct answer, D. Compton effect. Explanation. The Compton effect involves the particle nature of light, where photons collide with electrons, proving light's dual nature. Question 3. Interference of light occurs when their source is A. Monochromatic, B. Coherent, C. Close to each other, D. All of these. Correct answer, D. All of these. Explanation. Coherence is essential for interference, but monochromatic light ensures clarity, and close sources help the wavefronts overlap visibly. Question 4. In Young's double-slit experiment, when the distance between two slits is halved and the distance between slits and screen is doubled, then the fringe width is A. Remains same, B. Halved, C. Doubled, D. Quadrupled. Correct answer, D. Quadrupled. Explanation. Fringe width depends on both slit separation and screen distance, which is given as: if the distance between two slits reduces to half and distance between slits and screen is doubled, then new fringe width will become 4 times. Question 5. In Young's double-slit experiment, the ratio of fringe width of bright to dark fringes, A 1:1, B 1:2, 2:1, D 2:3. Correct answer, A 1:1. Explanation. Both bright and dark fringes are equally spaced because they are determined by the same interference conditions. Therefore, the ratio of fringe width of bright to dark fringe can be expressed as, by solving the ratio we get 1:1. Question 6. In Young's double-slit experiment, if white light is used, A. Bright fringes will be seen, B. Dark fringes will be seen, C. Alternate dark and bright fringes will be seen, D. No interference fringes will be seen. Correct answer, C. Alternate dark and bright fringes will be seen. Explanation. White light creates colorful fringes as its different wavelengths overlap, forming alternating bright and dark patterns. Question 7. When light is reflected from a dense medium to a rare medium, then its path, A. Remains same, B. Changes by half the wavelength, C. Changes by 1 wavelength, D. Changes by 3 times the wavelength. Correct answer, B. Changes by half the wavelength. Explanation. A phase shift of half the wavelength occurs when light reflects from a denser to a rarer medium. Question 8. Michelson interferometer is an optical instrument which is being used for the measurement of A. Velocity, B. Frequency, C. Amplitude, D. Wavelength. Correct answer, D. Wavelength. Explanation. The Michelson interferometer measures light wavelength by observing changes in interference patterns when mirrors are adjusted. Question 9. Mathematical condition of destructive interference in thin film is A. 1 wavelength, B. Half the wavelength, C. Odd multiple of half the wavelength, D. Wavelength plus 1. Correct answer, C. Odd multiple of half the wavelength. Explanation. Destructive interference happens when the path difference is an odd number of half wavelengths, leading to cancellation of light. Question 10. Which parameter of light does not change when light is reflected from a dense medium? A. Frequency, wavelength, C. Velocity, D. Amplitude. Answer, A. Frequency. Explanation. Frequency remains constant because it is determined by the source of light, while other properties like velocity can change. Question 11. In Michelson interferometer, a fringe is changed by changing the position of movable mirror at a distance. A. 1/4 the wavelength, B. Half the wavelength, C. 1 wavelength, D. Twice the wavelength. Correct answer, B. Half the wavelength. Explanation. Moving the mirror by half the wavelength alters the optical path difference, shifting the interference fringe. Question 12. Number of slits in a diffraction grating depends upon A. Speed of light, B. Frequency of light, C. Wavelength of light, D. Amplitude of light. Correct answer, C. Wavelength of light. Explanation. The number of slits is chosen to match the wavelength, ensuring efficient diffraction and sharp spectral lines. Question 13. If the wavelength of the incident X-rays is 2 times 10 to the power negative 10 meters, then the required number of slits per centimeter for its diffraction should be A. 5 million, B. 50 million, C. 500 million, D. 50 billion. Correct answer B. 50 million. Explanation. Slit width is given by wavelength of the X-rays is 2 times 10 to the power negative 10 meters. Putting the values and simplifying the expression, we get the number of slits per centimeter, 5 times 10 to the power 7, or 50 billion. Question 14. Which phenomenon has confirmed that light is a transverse wave? Interference, B. Diffraction, C. Reflection, D. Polarization. Correct answer, D. Polarization. Explanation. Polarization only occurs in transverse waves, confirming that light oscillates perpendicular to its direction of travel. Question 15. If the unpolarized incident light with intensity I is polarized to a Polaroid sheet, then the intensity of plane polarized light will be A. Half of I, B. Square root of I, C. Same as I, D. Twice of I. Correct answer, A. Half of I. Explanation. When unpolarized light passes through a polarizer, its intensity is reduced to half due to selective filtering of light vibrations. Question 16. Which one of the following cannot be polarized? A. X-rays, B. Radio waves, C. Ultraviolet waves, D. Sound waves. Correct answer, D. Sound waves. Explanation. Sound waves are longitudinal, so their vibrations occur in the same direction as wave travel and cannot be polarized.